A pleasant day to you, icons and lady icons. Welcome to the 6th module of our discussion in the subject Special Topics in Natural Science, in which we are going to talk about thermodynamics. So whenever we are actually talking about thermodynamics, it is actually concerned with heat and its transformation to mechanical energy. So from the name itself, thermodynamics, it's simply derived from two terms, which simply means the movement or the evolution of heat. In this chapter, we are actually going to encounter the following terminologies, and let's simply be familiar with every single one of them. Let's simply start with kinetic energy. Whenever we are talking about kinetic energy, it simply means that these are the different types of energy that is present in a moving body. So for instance, I am speaking at this very moment, you are moving, you are breathing, and you're actually doing different types of work. You're actually exerting here kinetic energy, or from the name itself, it is energy in motion. Then the next term, it is the presence of temperature. Temperature, it is simply referred or related to the random motions of the molecules in a certain type of substance, or it is known as the quantity or the amount. Whenever we are talking about temperature, this is actually measured in different ways. It can be measured on degrees Celsius, it could also be degree Fahrenheit, degree Rankine, and even in Kelvin. And if you can still recall on our module number 1, Kelvin, it is the SI unit that we are using for temperature. Okay, so basically whenever we are talking about temperature, it is the quantity of kinetic energy that is present in our body. Not only in the bodies of humans, but also in the bodies of different types of organisms and even different types of materials and objects. All materials are possessing kinetic energy because of the random motions that are present on their different molecules. So once again, whenever we are talking about temperature, it is the quantity of kinetic energy present on a body. Okay, so for instance, at this very moment, I just checked my temperature. And my temperature, it seems to be 36.7 degrees Celsius. So that is the quantity of temperature that is present within my body. Okay, so if you can still recall, when you are actually entering different establishments, if you went outside during this pandemic, temperature scales or temperature scanners are actually being used. And whenever a certain type of device is getting your temperature, it is basically getting the average molecular kinetic energy that is present on your body. Okay, so for instance, if you're actually going to do a lot of work, if you're going to do a lot of movements, more kinetic energy will be present in your body. So it means that the higher the temperature, your body will manifest. Okay, if you're doing exercises, your temperature will be higher than the temperature if you're actually sleeping or just doing less work. So heat, it is either defined as the quality of the kinetic energy present on the body, or the other definition, it is also known as the transfer of energy. Okay, so basically whenever we are talking about heat, it is actually defined into two major ways. Either quality or the movement of kinetic energy from one body to another body. And when it comes to heat, it is actually measured with joules. Okay, our unit or the SI unit that we are using for heat, it is joules. Unlike temperature that we are using degrees Celsius, Fahrenheit or degree Fahrenheit, degree Rankine, and even Kelvin. Okay, the SI unit that we are using for temperature is Kelvin, while the SI unit that we are using for heat is joules. Also, I also mentioned earlier the concept of work. And whenever we're talking about work, just like heat, we're also using here the SI unit known as joules, in which you're actually going to encounter if you already browse your module, or as we progress in this discussion, we are going to discuss the concept and the relationship between heat and work. Since we are talking about heat as one of the different concepts that we are going to discuss here on thermodynamics, let's simply have a recall on the different concepts that we are actually considering when it comes to the transfer of kinetic energy from one body to the next. Conduction, it is through direct contact. Convection with the use of fluids just like liquids and gases. And in the case of radiation, it is not the movement of energy by means of the utilization of the electromagnetic radiation. Since we are talking about the movement of heat, or basically the movement of energy, there are actually two basic concepts that we are going to encounter here, and those concepts are known as either the exothermic or the endothermic processes. All matter are actually undergoing a series of exothermic and endothermic processes until they disintegrated, or until they decompose, or until they break down. These are basically the other types of the movement of heat from one body to the next. Now, in the case of the exothermic and endothermic processes, we're actually utilizing here two major terms. The first one, the presence of the system, and the second one, the presence of the surrounding. So if you can observe here, we have the presence of two Erlenmeyer flasks, and this flask is considered as your system, while the outside of your system, it is now known as the surrounding. So, on the second Erlenmeyer flask, we have here once again the presence of the system, then the exterior of it is the surrounding. In my case, I am the system, my room, it is the surrounding. Okay, so basically, that is the concept that we are going to apply when it comes to the endothermic and exothermic processes. Exothermic and endothermic processes actually explains how heat moves from the system to the surrounding, or vice versa. Exothermic process, from the name itself, it is now the movement of heat away from your body, from the term exo, which means outside. Okay? Exothermic processes, it simply means that the temperature, kinetic energy, and even heat will move out from the system. Okay? So basically, the system is releasing energy to the surrounding until they reach equilibrium, or until they reach the same temperature. Okay? While in the case of the endothermic processes, it is now the movement of heat towards that system. From the term itself, endo, which simply means inside or going inside. Exothermic processes, once again, it is the movement of heat from the system to the surrounding. While in the case of the endothermic process, it is now the movement of the heat from this surrounding to the system. What are actually the different evidences that we can use when it comes to exothermic and endothermic processes? So basically, those are actually the simple things, or the simple analogy that we can use when it comes to exothermic and endothermic processes. Now, other examples. For instance, you're eating ice cream. You get a scoop of ice cream during a very hot summer day. What are you going to observe after 5 or 10 or even 20 minutes after you scoop that ice cream? And you're going to observe that the ice cream will melt. So basically, the reason why that ice cream is melting is because the ice cream is absorbing the heat that is coming from the environment. So if the ice cream is absorbing the heat, what type of process is happening? It is basically endothermic process. Okay? The ice cream is melting because of the presence of the movement of heat from the surrounding to that ice cream. Okay, so now last example. You cook instant noodles. Then after you cook that ramen, or I'm not sure what is the brand of that instant noodles that you like, after some time, you forgot that you actually cooked it. You left it on the table half an hour, or basically 1 hour. Then, when you return, you observe that the noodles, the instant noodles, it is now basically cold. It is no longer hot. So what process happened when you left that instant noodles, that cooked instant noodles on the table? So basically, the reason why it cooled down is because the energy that is present on the instant noodles was simply diffused in the environment. It moved from the instant noodles to the environment. So basically, that is the reason why it cooled down. Okay, so that is actually the application of exothermic process. Every single object that is present around us are experiencing different types of these reactions, either exothermic or endothermic processes. Then, this is basically a clue. If that body heats up or kapag uminit, that is an example of an endothermic process. Pero kapag ito naman ay lumamig, it is one example of an exothermic process. Okay, because basically the temperature moves out of the system, exothermic. If the energy moves in, that is now endothermic processes. Now, how are we going to apply this with the phase change? Okay, there are actually different types of concepts that is actually involved in the change that is happening on different substances. So as you can observe here, we're actually possessing here a certain type of line or an arrow that whenever the temperature is increasing, the state of matter basically changes. If you can recall the kinetic molecular theory of matter that is basically present on your discussion on Science 8, this actually its application. That the higher the temperature, as the temperature increases, the space that is present between different molecules are moving away and away and away with each other. Then as the temperature decreases, those molecules will now move closer and more compact with each other. So basically, the different things that is actually happening around us are dictated by the movement of the energy that is present from one body to the next. It is either in the form of a system or the surrounding. Thermodynamics. When it comes to thermodynamics, there are actually different laws that governs this discipline. And when it comes to your higher sciences, probably on your physical science, and if you're going to pursue the engineering field, more discussions will be considered on this subject. There would be a special subject when it comes to your collegiate level regarding thermodynamics, the application of chemistry and physics on the actual material science. Now, according to the first law of thermodynamics, energy cannot be created nor destroyed. It can only be transferred or changed from one form to another. In the first law of thermodynamics, we're actually going to encounter here different variables. Specifically, the first one, it is delta capital letter E, or delta, it represents the change in energy. And the energy that we are talking about in this thermodynamics, it is now the kinetic energy that I mentioned earlier on the earlier part of this discussion. Then, other than the change in energy, we're also going to consider here small letter q, which is now the representation of heat. And once again, whenever we're talking about heat, it is now related with the concept of capital letter W, which is now work. Change in energy, heat, and work, all of them are possessing the SI unit known as joules. Okay, so the unit that we are going to use is joules. Okay, so this is the first consideration that we are going to have and discuss on the first law of thermodynamics. Second consideration. In thermodynamics, we're also using here different types of keywords that will actually determine what would be the sign of the number or of the integer that we're actually going to utilize when it comes to the heat and at the same time work. Okay, so these signs will signify us the clues if we are going to consider a positive or a negative value for heat, a positive or a negative value when it comes to work. So what are those keywords? Let's simply start with the positive signs. Now, whenever we are talking about the concept of heat, if you encounter the following terms on any problems, for instance, absorb, add, and even accepted, or any terminologies that are related to these keywords, the value of heat is positive, or basically, it gained. Okay? If the value of Q is positive, it gained energy. Now, when it comes to work. The value of work will be positive if we are going to utilize the following terminologies. The first one, compress. Also, the term applied. From the terms itself, we can now determine here that whenever we are talking about positive work, there is basically an effort done. Okay? You can see here the clues when it comes to the values of the integers that are present both for heat and work. For it to be positive, heat should be gained and work should be done, or effort is done. Okay? Then, for the integers to be negative, we are now going to consider the following criteria or the following keywords. For heat to be negative, then add, its synonym is to remove. Then, when it comes to accepted, it is now either release, removed, or even the term decrease or subtract. Okay? So, basically, for heat to be negative, the heat should move out of that system. Okay? Now, when it comes to work, for us to have a negative value for work, we are now going to use the following terminologies. The first one, it is expand. Then, the second term is the system did the work. Okay, so basically, if you can recall now, whenever we're talking about the heat or the Q, it is all about the system. While when it comes to the work, it is now all about the surroundings. So basically, those are just the things that you should remember when it comes to this, if you're going to apply the concept of the first law of thermodynamics on different problems. And speaking of which, let's simply start with this problem. A gas inside a container releases 35 joules of heat, while 84 joules of work was done to compress it. What is the exchange in the internal energy of the system? And what process is involved in this scenario? Okay, how are we now going to determine if it is an example of an exothermic or an endothermic process? Okay, now, just like what we usually do from the previous problems, we're now going to utilize here the Gressa method. Let's simply start with the given. Our given here in this problem, the first one, we can observe the presence of heat. And heat, it is equivalent to 35 joules. Then, also on the problem, it mentioned that the work done is 84 joules. Now, before we proceed with the required equation solution and answer, let's consider first what are the integers. Will they be positive or will they be negative based on the keywords that are present on the problem? Let's simply start with heat. According to this problem, a gas inside a container releases 35 joules of heat. So, if there is the presence of the keyword release, what will now be the sign of our heat or the heat that is present in this problem? It is negative. Once again, why is it negative? Because heat is released. Going back on your cheat sheet, it means the value will be negative. Then, when it comes to work, let's consider if it is positive or a negative sign. According to this, while 84 joules of work was done to compress it, the keyword is compress. So now, if the keyword is compress, is work done or not? Basically, the work is done. So, it is still a positive sign. Okay, so when it comes to work, it is positive. When it comes to heat, it is negative. Then the next one, we are now looking for the required, which is change in energy. Then, our equation, change in energy is equivalent to heat plus work. Basically, this is just the formula that we are going to utilize for this problem. Then, for solution, delta E is equivalent to our value of heat. It is negative 35 joules plus our value of work, which is 84 joules, which will now give us the answer that the change of energy that is present in this scenario will simply give us 49 joules. Now, since the value is positive, the change in energy is positive, it is now an example of an endothermic process. Okay? It is an example of an endothermic process if the value of delta E is positive. But if the value of delta E is negative, it is now an example of an exothermic process. Remember, if the value of delta E is positive, it is an example of an endothermic process. If the value of delta E is negative, it is now an example of an exothermic process. Now, let's consider another example other than what is mentioned on your module. Now, in this problem, a liquid releases 55 joules of heat as 72 joules of work was done by expanding its particles. What is the change in the internal energy of the system? What process is involved in this scenario? Okay, so once again, we are going to use the GRESA. Let's start with the given. We have heat. According to this problem, the heat it is equivalent to 55 joules, while work is equivalent to 72 joules. Now, if you're going to utilize the cheat sheet that is related to the concept of the different keywords, we're now going to consider if the heat and the work is either positive or negative integers. Now, from the problem itself, it states that a liquid releases 55 joules of heat. Our keyword is release. So the value of heat, it is basically negative since heat is released. Then in the second variable, it states that 72 joules of work was done by expanding. Expansion happened. So basically, the value of work, it is negative as well. Then, we're looking for the required. And our required, it is once again delta E. Then, for our equation, it is now the change in internal energy or kinetic energy is equivalent to heat plus work. Then our solution, delta E is equivalent to our value of Q, which is negative 55 joules, plus the value of work, it is negative 72 joules. Now, for our answer, change in internal energy, it is now equivalent to negative 122 joules. Now, what is the process that is involved in this scenario? Since the value of change in energy is negative, it is now an example of an exothermic process. After the first law of thermodynamics, let's now consider here the second law of thermodynamics. When it comes to the second law of thermodynamics, we are now considering here the concept of entropy, or simply the state of order and disorder of an isolated system always increases. So basically, if you're going to use an analogy when it comes to the second law of thermodynamics, so for instance, we have here two pieces of identical tissue paper. And if I am going to tear this piece of tissue paper, which of this is possessing more entropy? Is it A or is it B? Second law of thermodynamics basically states here that the disorder that's present in a system will always increase. Or basically, as we can observe here, if we're going to crumple or even if we are going to tear this piece of tissue, it will actually create more entropy than this piece of tissue paper that you are just going to crumple. Okay? This one is possessing more entropy, it is possessing more disorder than the other set of tissue paper. Or basically, every single matter that is present around us will have a disorder state. And that is actually normal when it comes to nature. It is basically natural for humans to die, for organisms to die, for things to deteriorate. Because that is how the universe, that is how the thermodynamics governs every single one of us. At the end of the day, we're going to meet our demise. And lastly, the last law of thermodynamics, it is now the concept of the absolute zero, in which the absolute zero or 0 Kelvin cannot be reached by a finite number of steps. So basically, the 0 Kelvin, it is just considered as a theoretical value. And when it comes to 0 Kelvin, theoretical physicists are actually arguing here that there's a possibility that once a material reaches 0 Kelvin, all of the spaces that is present on every single atom that is present in this material will move closer and closer and closer to each other until it reaches a point that there will be no longer any space that is evident between subatomic particles and between these atoms. So basically, when it comes to the third law of thermodynamics, we are now actually applying here the concept of entropy also. This is actually one of the reasons why solids are possessing less entropy unlike liquids and gases. So this is simply the end of my discussion for this module. So for those of you who actually reached this part of the module, I am actually going to give additional points. You're actually going to receive additional 10 points on your problem set if you're going to write an absolute zero on the lower portion of your problem set sheet. So once again, please write there the keyword absolute zero for you to receive additional 10 points on your problem set. So that's all for the meantime. Thank you for listening to the last discussion that we are going to have for the physical science aspect of natural science. On the next quarter, we're going to discuss here more of the biological sciences aspect, and I am hoping that you're going to enjoy those discussions. Paalam!